This is John Black, Super Chemist. This is not an instructional video. It is just a vlog showing a video account of some chemistry experiments I have done or am learning about. I do not go over all safety concerns, so if you repeat anything in the video, you do it at your own risk. This is part 2 of making ethyl bromide. You've seen I just put a tiny bit of the polar stuff in, meaning this, the base. And so that's, you can tell it's the top layer, obviously. And plus, ethyl bromide has like a density of 1.45 or something. I mean, it's pretty high density compared to water, which is 1. So the water stays on top, and the ethyl bromide is on the bottom. So when this, each time you do these washings, you should let this sit for 20 minutes, 15-20 minutes at least. Sometimes I let it sit for an hour, you know what I mean? The longer you let it sit, the better, you know what I mean? But don't get crazy about it. You drain out your ethyl bromide and then keep it. Drain out the aqueous layer and put your ethyl bromide back in so that you can do the next washing. And another thing about when you're basically when you do this, you're trying to extract something out, you know what I mean? When you do extractions like this, it's actually better to do smaller amounts. Like, let's say this water, right? Let's say I wanted to wash it with 100 milliliters of water to wash whatever I'm washing, right? Now, you could use the 100 milliliters, but it would be better if you used 2 washes and did 50 milliliters each. And even better than that would be to have 4 washes with 25 milliliters in each. And even better than that would be to have 10 washes at 10 milliliters each time. The smaller it is, it seems, the better it is, you know what I mean, to get it out. You know what I mean? If you're going to use the same amount, don't use large amounts. I just put a dab, I mean, you can see, I just put a dab in there, and that's good enough. You don't, you know, if you want to put more in, do multiple washings, you know what I'm saying? Because, like I said, I'm going to wash it twice with this, and maybe even twice with this. I should. And whatever I wanted to wash it with, you know, like I want to wash it with maybe 50 milliliters, 30 milliliters more like. So that'd be 15 milliliters each. You know what I mean? You don't want to put 30 and 30 in. So it's been 20 minutes, so I'm going to let it come out, drain out. And now I can move this aside. This would be the product, obviously. And get rid of that water now. And remember to make sure that the stopcock is closed. And put your ethyl bromide back in there. Now I'm going to use the sodium bromide, the sodium carbonate again. I'm going to wash out this, right? Put a little bit in here. Wash it out some more. This is probably good enough for this. And then I'll put it into here to wash this out. Put a little more. Turn it upside down about 3 or 4 times. Oh. Remember, every time you do it about 3 or 4 times, you got to bend it. Give it a swirl. Make sure you can bend it. Put that whole with the, the crevices so it can leak out gas. It builds up. Let it sit 15-20 minutes. So I'm not going to show the rest of these washings or whatever. This is the last washing with the sodium chloride. And I'm going to, now this container, I've been using this container every time I empty the ethyl bromide into something, right? And then on the next washing, I'd wash this out first and dump it in. Like if I was going to use sodium chloride, I'd dump it in here, wash this out, and dump it in. Now I have a brand new cup, so that it doesn't have any water or anything in there from the previous washings. You can see it's very, can't tell the difference between the water and the product. I mean, they're both crystal clear. Alright, so there's the product. You can see it's right in between 125 and 150 milliliters. Crystal clear. Now I'm going to put some cellophane over this and cool it down in the refrigerator because I don't know if adding calcium chloride is exothermic or not to this. I really can't remember. So I'm just going to put some cellophane on here real tight. Put a gum band around it. Put it in the freezer. I got it down to 0 Celsius. I'm going to put a stir bar in. And then the first thing I'm going to put in is magnesium sulfate because it's so cheap. And I have a whole bunch of it. It's anhydrous. So I'll just throw a little bit in. Maybe even a lot, I guess, compared to that. I'll put the stir bar on. And I'll let that stir for about a minute or two, you know what I mean? Soak up as much water as I can. Because the next thing I put in, which is really the only thing you need to put in, is some calcium chloride that's anhydrous. Now this stuff is more expensive, so I don't like to use as much of it. Now if there's any alcohol in there or anything like that, it'll help soak that up plus the water. So let me throw that in. Well, that did go up to 7 degrees like within 30 seconds it's been out of it. So it is exothermic a little bit. That's 7 degrees Celsius or 14 degrees Fahrenheit there, raised up within 30 seconds, well, a couple minutes of adding this stuff. Then I'm going to put some nice clean cellophane back on there. Get it all nice and tight. Put the gum band back on. And we'll let that stir. You can see it clumping up. That might be the calcium chloride. But anyways, I'm going to try and get any water out of there, any alcohol. And I'm going to let that stir. I'm going to let that stir for like 15-20 minutes. And then distill it out. Alright, so that's been stirring for a while. And I'm going to filter it and put it into this round bottom flask so I can distill it. I'll get all them solids in there. Use a little vacuum assist. Alright, so I'm just going to put some little bit more calcium chloride in here that's anhydrous. A little bit of boiling stones, and we're going to distill that. See what temperature comes over and see what's up with it. Alright, so here's my setup. Got a Vigrex column. There's my water cooled condenser. It's already coming over. As a matter of fact, this came over first. This 25 milliliter round bottom flask. It was kind of low, a little bit too low to be considered ethyl bromide. So I switched it over, and now I'm collecting ethyl bromide right now, bromoethane. So when this gets done, I'll let you know. Alright, so there's the receiving flask. It's done. Let's pour it out and see how much we got. I don't know if you can see that. It's slightly above 125 milliliters. Oh, there we go. See, it's slightly above. Maybe 130 milliliters. Alright, there's the equation for the reaction. I got the used 470 milliliters of ethanol. It's 50% by volume, so that means 235 milliliters was actually ethanol and the rest was water. So I divided that by the molar mass or the molar volume of ethanol, and I got 4 moles. I used 4 moles of ethanol. Down here, I used 270 milliliters of concentrated sulfuric acid. I'm just guessing. Yeah, I mean, you could say it's anywhere from 53 to 56 milliliters. I never really titrated it. But 53 milliliters comes out to 5 moles, so I used that. So I got 4 moles of alcohol, 5 moles of acid. Sodium bromide, here's the molar mass. I used 210 grams. It was 99% pure, so really only 207.9 grams of sodium bromide. I divide the molar mass into the amount I used, and I got 2 moles. So I used 2 moles of the sodium bromide. Now the bromoethane, here's the molar volume. If I multiply that by 2, because the limiting reagent was sodium bromide, and I used 2 moles of that. So I'm doubling this by 2 to get my theoretical yield. That's 149.27 milliliters is my theoretical yield. Now, I said I had 130, somewhere around there, but I put it into this to measure it even better, and it came out to be 125 milliliters. So I take the molar volume divided into 125 milliliters. I get 0.837, which is 84% yield. Now, what did I do different in this video that I didn't do in the original video where I made ethyl bromide? The only difference is that I used more acid, sulfuric acid, and less water. The ratios of everything else, like the sodium bromide, the ethanol, they're the same. You know what I mean? I used twice as much ethanol as I did sodium bromide in both videos. But I used slightly more sulfuric acid and slightly less water this time. That was the only difference, and it raised my yield up from, I can't even remember, it was either 65 or 70%, somewhere around there, 68%, somewhere in there, up to 84%. Now keep in mind, you know, each time you do this, you know, you get a slightly different whatever. Usually I get between 83 and 88%, okay? So 85%, say, on average. I got an 84% this time, screwing around with the camera, and I just wanted to do it in a hurry because I already did this video once before. But I figured it was worth doing it again because of, I mean, I almost raised it up 20% more, you know what I mean? It used to be 64% or slightly more. Now it's 84%, you know, my yield. So I think it's worth doing this second video, and I hope it helps out some people. The density of ethyl bromide is 1.46. I usually get a 1.44 to a 1.46. So the density is pretty much on the mark. I mean, keep in mind my scales aren't the best in the world. They're not scientific scales. So 1.44 is actually pretty good, I think. Anyways, y'all have a great day, and always remember, science is great.